All right, we're going to go over the notes for section 1, 2, and 6. These are also sections that you should look over and read through in your book as it pertains to some of these definitions, making sure that you have the notation correct also. So if we look at talking about legs, legs of a triangle, if we look at the legs here, our legs would be right here and right here. If we look at this one, our next triangle, you could see our legs would be right here and right here. A hypotenuse in a right, and it has a 90-degree angle triangle. What is the hypotenuse for triangle ABC? And if we look, that is right here. What is, the vertex of a triangle? How many vertices are there in a triangle? There are 3. And what are the vertices in this triangle? They are A, B, and C. So here we look at a vertex angle in an isosceles triangle, asking us what is the vertex angle, and that would be angle A. What is the base angle in this triangle? Or what is the base in this triangle? If we look here, the base is going to be right here, which is CB. The base angles. So if this is the base here, then our base angle are angles C and B. Next, interior angles. If we circle the interior angles on the inside of the triangle, and if we circle the exterior angles, okay, so like I said, definitely more explanation if needed, and diagrams and pictures in your book. These are things that should become part of our note cards, to become part of our vocabulary. Okay, let's continue along. And we're going to look at our first theorem here. And it is the triangle sum theorem. And the sum of the measures of the angles in every triangle is 180 degrees. And so we want to be able to prove that. Okay? We're given a triangle ABC, and what we need to prove is that if we add up those interior angles, angles 1, 2, and 3, that they equal 180 degrees. And before we get going, we're going to take and extend the sides of this triangle to be able to prove this. And we're going to show one way of being able to prove this. There are several different ways. We're looking at one way. So what I'm saying is that if you were to Google triangle sum theorem, you might see a slightly different technique taken in this proof. Okay, so let me take and extend this side here and extend through point A line. Oops. Okay. Try that again. There we go. And these two lines are going to be parallel. And I'm going to take, and we created some angles in here, so I'm going to label this angle 4 and this angle 5, and I'm also going to place a point here and call it D. And if we follow through here, first thing it says in our statement is that if we look at angle 4, which is right here, and angle BAD, which would be this angle here, BAD, that those are a linear pair. And that is true. And the reason for that is that that's the definition of a linear pair. Now, what we know about that then is that if we have angle 4 and angle BAD, that those are supplementary. And the reason for that is that if we have a linear pair, that implies that we have supplementary. Now, if we continue on with that line of reasoning or statements and reason, the next thing is to be able to look at the measures. And so if we say we have the measure of angle 4 and we add to that the measure of angle BAD, that would have to equal 180 degrees, and that is the definition of supplementary. So now what we have up here is we have angle 4 plus the angle BAD, which is this larger angle, that those are supplementary and equal to 180. And we're going to have to somehow move that so that we can get angles 1 plus 2 plus 3 equal to 180. And that's going to be what the second part of the proof is going to help us with. Okay, so let's keep going along here. The next thing says that the measure of angle BAD, which is, as we've discussed, this angle here, BAD, this angle here. And then if you remember, I had marked in that this was angle 4. Whoa. That this was angle 4 and this was angle 5. So we're going to say that measure of angle BAD is actually equal to the measure of angle 2 and angle 5. And that is true by the angle addition postulate. So that's not one that we used last chapter very much, but we're bringing it back in this chapter. So now if we look at what's next here, if we had the measure of angle 4, so I'm going to drop that down, the measure of angle 4, and we add to that, we said we had the measure of angle BAD, but we now said that that is combined of measure angle 2 and the measure of angle 5. So I'm going to substitute in the measure of angle 2 and the measure of angle 5, that's going to equal 180, and that's by substitution. So basically I took that, the measure of angle BAD, and I broke it down into its two parts, the measure of angle 2 and the measure of angle 5. Okay. Now from there, we're going to look at what's next, which then tells us that angle 1 is congruent to angle 4. Well, let's locate where those are. Angle 1 is here and angle 4 is there. And if you think about what we have here, if we were to extend this line also, is that we have two parallel lines cut by a transversal. And if you look at where those are located, those are alternate interior angles. If you do something very similar and you extend this line here, we have two parallel lines cut by a transversal, and once again these two angles, angle 5 and angle 3, are alternate interior angles. And so what we know is that if we have parallel lines, that implies that our alternate interior angles are congruent. If we know that they're congruent, now what we can say is that the measure of angle 1 is equal to the measure of angle 4, as well as the measure of angle 3 is equal to the measure of angle 5. And that, of course, is our definition of congruency. Now, if we look at what we have here, if we go to try to transform from step E to step H, we can see that the measure of angle 2 is there, and it's still there. But what's happened is the measure of angle 4 is now in place of where angle 1 is, because we've said that to be true up here. And the measure of angle 5 has now been replaced by the measure of angle 3, because we have said that here. And therefore replacement tells me that that is substitution. Once we have that angle 1 plus angle 2 plus angle 3, which is what we have here, is equal to 180. Now we have our proof, and we can now use this in other proofs, and our reason is going to be our triangle sum theorem. Our last part for this set of the notes, I'm going to go through and just go through the explanation for, and if you want to, you can go through and do this experiment, this investigation with some paper, but we're going to look at the conclusion here, what would happen. And the conclusion is that if we have the measure of angle 1, so this measure here is angle 1 right here, that is going to be equal to the measure of angle 2 plus the measure of angle 3. So if we were to add up 2 and 3, that would equal the measure of angle 1.